Hello students, my name is Rahul and I am your coach and mentor of physics. Today we are going to talk about one interesting topic called as projectile motion. So we in our day-to-day life or whenever we are watching some movies or war situation, we have seen that a cannon is launched like this and it lands from here to here. This cannon launching student is nothing but application of physics which is called as projectile. Let's see how we are going to see this projectile motion and how we are going to analyze this. We know that there are two types of motion. One is called as horizontal motion and one is called as vertical motion. Okay. We know that there are two types of motion. One is called as horizontal motion. A bus moving on the road is an example of horizontal motion. You throw a ball upward. This is an example of vertical motion. But this motion is a combination of both horizontal and vertical motion. So this is a combination of student both horizontal plus vertical motion. So let's see how we are going to analyze this horizontal and vertical motion combined together. So if I draw the point of trajectory, if I take a screenshot at different instant, say I launch the ball from here and I am taking the screenshot at different position. What I'll get here in this direction I will have a vertical direction of motion, and here in this direction I have a horizontal, this direction I have horizontal direction of motion, and this direction I have vertical direction of motion, isn't it? So what is happening here, when it is going from point A to C, this is the highest point. This is the highest point of motion. Here we assume that their friction is negligible or we can ignore the friction. So at highest point we see that there is only horizontal direction of motion. Only horizontal direction. So this horizontal direction is always fixed. So in projectile, in horizontal direction, what is happening? The forces are balanced, my dear student. In horizontal direction, forces are balanced. So velocity constant. If force is balanced, I can say the velocity is constant, right? So this direction of motion which was in horizontal, which I named it as Vx naught, this is always fixed. This Vx naught is always fixed. Okay. In vertical direction, my dear student, in vertical direction, the forces are not balanced. In vertical direction, forces are not balanced. Forces are unbalanced. So what will happen if forces are unbalanced? What I can say? I will say that there will be acceleration, and acceleration G act in downward direction. Acceleration G in downward direction. Acceleration G is there in downward direction always. Always in horizontal, in vertical direction, G will be acting. So if I write here the motion in vertical direction Vx, if I write here, it will be Vx naught. And if I write in terms of vector, it will be U cos theta. This is the component, theta is the angle, so it will be U cos theta always, right? This is the horizontal direction. In vertical direction, in Vy, it will be U sin theta minus Gt. This is U and this is Gt. U sin theta minus Gt. This is my velocity in vertical direction. So what we see, when at point B and point D, they are in same horizontal level, their magnitude is same. At point B and D, the magnitude of velocities are same, but the directions are opposite. So at B and D, mod VB will be equals to mod VD, right? C is the highest point, student. Okay, so let's see what we understand from here? We concluded that velocity in horizontal direction is constant as the force, there is no force acting in horizontal direction. In vertical direction, the velocity changes as there is unbalanced force. Okay, so unbalanced force, the velocity will be acting it here. So whenever we are launching a projectile, it is easier to analyze when we analyze from peak to landing and launch to peak. If we analyze the motion from A to E, the time it takes to reach from A to E, this point, this is called as time of ascent. And time it reached to take from this highest point to the bottom point, this is called as time of descent. So time of ascent, my dear student, and time of descent, this will be equal, right? Time of ascent and time of descent will be equal. So if I summarize this whole point, at highest point of the motion we have studied that the velocity will be 0. Vertical velocity at the peak will be 0. The magnitude of velocity at point B and D will be same. The horizontal velocity is same everywhere as there is no horizontal force acting in this direction. If we have a balanced force here, okay, the time it take to reach from A to C will be equal as time it take from C to E. That is, time of ascent will be equal to time of descent. The time to move from A to E is same when analyzing horizontal or vertical motion. So this is what we concluded, right? So if we talk about the projectile, we can talk that the projectile, when the theta is 0, when we are projecting at like this will be a horizontal projectile. Okay, when I am at the top of tower, my dear student, and I project like this, so this will be a horizontal projectile. Horizontal projectile. So in horizontal projectile, student, I can write here the range can be written as nothing but my initial direction of velocity u by under root this time. The time will be nothing. If this is the height, I can write this time is nothing but 2h by g. So this will be my range for the horizontal projectile, right? This I hope you can analyze. So this is the horizontal projectile. From a top of a tower, I am projecting it horizontally. My theta will be 0 here, my dear student. Now, if I project it vertically, my theta will be 90 degree, right? So this case already we have studied in our previous chapter. Now, theta is the most general case. I project it from any angle, and this is the case generally which we analyze here. So this is a basic analysis of the projectile which we are going to see here, and if you understand all this point which we discussed, this is the most fundamental knowledge of the projectile. So I hope if we analyze the motion in a horizontal and vertical direction, it is easier for us to visualize the whole concept of projectile. Projectile can be visualized as a combination of horizontal and a vertical motion. Okay, so this is how we are going to conclude on this chapter. So we are going to conclude here right now, and we'll continue this discussion further. So that's all for today. Thank you, my dear students.